Hey Cedar Valley chemistry students, how you doing? It's Mr. E here. Hey, I know we've been talking about matter, and I thought I'd sum up a little bit here and show you some demos about the lesson that's coming to you, this third lesson of the week. So just to sum up, we were talking about the states of matter in the last couple of lessons, and basically the fact that that matter is really just the way the particles are arranged and how it changes with energy. So we have the different phases. But one of our focuses here is on what happens when you change those attractive particles, okay? And so the first part we did was we talked about solids as a summary of the last lesson and the difference between ionic and covalent solids. And so that's important to remember with this too. Remember, an ionic compound is made with a cation and an anion, positive and negative. And covalent molecules are made with the nonmetals. The ionic compounds are the strongest bond. So we're dealing mostly with liquids, we're dealing with these covalent molecules, these nonmetals. And we ended the quarter basically talking about polar molecules, or ended the semester talking about polar molecules. And that's when the molecule has a positive and a negative side to it. And that has a lot to do with how liquids act. So let's do some demos and we'll talk about it. And I'll give you some idea of some of the terms and things that are coming up. Okay, so we're going to do some demos here. Basically, we're talking about the attractive forces between the molecules in the liquid and also between the molecules and things that surfaces the liquid comes in contact with. So here's a demo. My assistant, Madeline's going to come on over here and zoom right in on this little bit of wax. I have some candle wax right here. And very simply, I'm just going to take a little spoon of water. And what do you think is going to happen to the water when I put the water on the wax? All right, so I put the water on the wax, and you can see that the water beads up. You can see different balls of it right there. I could actually pick a little up and move it around, and if I push it around, it makes little balls on the wax right there. And so that is a property of water. Let's look at something else I have right here. Okay, I'll wipe that out. Now let's try some isopropyl alcohol, which you know is rubbing alcohol. You've smelled that many times in class, passing that around, okay? So we'll put some of that on there. And I don't know if you can see, it's hard to see, but no matter what I do with it, it doesn't ball up. It does not make those round little beads that water does. So that is a property known as cohesion right there. And so cohesion is the attraction between the same molecules. So the water molecules are attracted to each other and they stick together in a ball right there. The attractive forces are strong enough for that. So here's another demo I'm going to do here now along the same lines. I think you've seen me do this one in class. And I have this lovely creamery bottle right here in a screen, and I have it mostly full of water. So I'm going to just finish filling it up, show you that actually, yes, it is a screen. Nothing up my sleeve, okay? And so now it's full of water there. There's my screen. I'm going to turn it over and let go of it, okay? So you can see what's holding that on there, all right? I just love that. There's a number of factors, but talking about the liquid, there's two things that are going on right there. And I can shake it and I can even drop it off right there. And it doesn't have to be full. I can do it with this much water too, I think, okay? So what's going on is there is cohesion in there. The molecules of water are sticking together and making them too big to fit through the screen. There's another property called adhesion, and that's how the molecules in the water, how well they're attracted to the molecules in the screen and the glass. And so the adhesive property is holding the screen onto the glass jar, and the cohesive is keeping the water from going through the screen. So there you go. So there we have both cohesion right there. So remember, cohesion is attraction between molecules, the same molecules in the same substance. Adhesion is the attraction between the molecules in one substance and how well they like the molecules in another substance. Okay, so those are a couple of the main properties, and those are determined by the attractive properties of the molecules in the liquid. Okay, so if you look in here, you can see that a paper clip is floating in water. And that is known as surface tension. And different liquids have different surface tensions depending on how attractive the forces in the water are. They pull on the surface of the water and give it kind of like a membrane to it. So here's the deal with surface tension right here. You look up here, surface tension then, is you have all the attractive forces between the molecules in the water. They're pulling in all directions, but these guys and gals, they can't pull up. So they actually end up pulling stronger on each other in this direction because there's nowhere to pull up here and they want to be attracted. So they make, depending on the attractive forces, you get a surface tension there. Water has a strong surface tension. That's why you see water striders and other insects on it too. Okay, so here's another example of surface tension and how things can ruin surface tension. So I've got some water here. I put a few chili powder flakes in there, okay? You can see them floating on the water pretty nicely there, just hanging around. And I'm gonna put just one drop of dish soap, Dawn dish soap, right in the middle of that and see what happens. And there they go. So what happened there is the dish soap gets in there and it interferes with the bonds in the water right there. And there's more other stuff going on, but you can see that the surface tension changes pretty dramatically there when you put the soap in there. So that's pretty cool, okay? I was also talking about, or showing you alcohol in water. Now, how many particles there are, this isn't really in the lesson, but you should keep this in mind. We might do some math on it coming up, but how many particles there are in water is part of the density of the water. So I've got water and I've got isopropyl alcohol here, and I tried to put the same amounts in there. They're pretty darn close, okay? So they have the same volume. They take up the same amount of space right there. And if I weighed them, I might see that they weigh differently, because if there's more molecules in the water than in the alcohol, then the water would weigh more and the water would be denser. There's more atoms, there's more molecules crammed into that volume compared to that one right there. And let's see if that's true. So here's what I have. I've got some ice right here. So let's see what ice does. I'm gonna put some ice in the water right here, okay? So there's the ice. You can see a couple ice cubes floating in the water. So here we go. I'm gonna put some ice right into this alcohol now. Okay, let's see what happens there. So you can see quite a difference going on right there. The density of the alcohol is less than the density of the water. And so the water will hold up the ice on its surface. And that's because there's more attractive, more particles in there. Okay, so that's another example right there. That's the density, and that's also has to do with the cohesion of the molecules in the liquid as well. Not so much adhesion. Adhesion is when it's sticking to something else. Okay, and the last thing we're going to do here, and then I'm going to do a couple things on gases, which there's two things which are kind of a review and something new as well. So the last thing I'm going to do here is the last topic of this is, on this week's lesson, is viscosity. And viscosity is the term that they use about basically how thick something is. And how well it, viscosity, and so it's really how much it resists flow. So something with low viscosity has more room between the molecules and they can move around and flow more. Water would be an example of something with low viscosity. High viscosity, it's thicker, the particles are closer together, they're more attracted, probably like maple syrup. Okay, so you would have a low and a high viscosity. The last thing I want to talk about is you did a couple of quizzes for me, and the first one was short answer. And I asked you two questions kind of similar in there, and they are really related to what we're studying now. The last topic this week is on gases and the kinetic theory of gases, which says gases move around with a lot of motion. They move in straight lines until they bump into something else. They never lose their energy when they move around. And one of the big ideas we're going to work on is the idea that when you change the temperature of a gas, you change the volume and you change the pressure. And so I had a couple questions on the first quiz. One of them was, what was the one about a balloon, okay, and then putting it in a freezer right there and compressing a gas. So what I have right here is I have a balloon right here. It's got a little bit of water on it. And my balloon is actually one of my gloves. And believe it or not, it actually has a gas in it right there. It has a little bit of air in there, and the gas moves out, and it tries to fill all the spaces. How do I know there's a gas in there? Let's see if I can compress it. So you can see, and this is one of the topics that's coming up that we talk about today. One of the ways I can change the pressure of a gas is I change the volume. So I've taken the volume of that glove and I've made it smaller, and so the particles don't have as much room to move around right there, and they increase the pressure. You can see that. So yes, I can compress a gas right there. Okay, and so the last thing I want to show you again is dealing with gases and what happens when you either heat it up or cool it down. So I have another glove that I blew air into it and made it pretty much the size of my hand, and then I put it in the freezer at lunchtime. So let's take a look at that glove and see what size it is right now. There it is. And so this is the question I asked. Now you can see this is going to happen very quickly, is that as soon as I put that glove on my hand, you can see it's starting to fill up again. It's starting to fill right up right there, and that's because the heat from my hand is exciting those gas molecules in that glove right there. They're bopping around more, they start going faster and faster. And gas pressure is simply the sum of the number of collisions of the gas particles on the walls of the container, in this case the glove. So there you go, and now you can see that glove is filling right back up again, and it's just from the heat of my hand. Okay, so that's lesson 3 right there, and make sure you do that and get that in this week, because they're taking attendance on filling things out, and I'll hopefully do another video for you next week.